right, welcome back. It is Tuesday, April 13th. This is your lesson for science for today. Unlike some of my other videos where I mostly just go over the directions, this is actually to teach you what you're going to be doing in this week's work. So please make sure you watch this video all the way to the end. All right, so last week I had you do a gizmo that was all about sight versus sound reactions. It was carrying out an investigation and drawing a conclusion. That's the science skill that we're working on this week again. In that investigation, you had a question that you were trying to answer. Is sight or sound faster for reaction time? You did a systematic data collection over the course of 5 trials. You collected it in a table. You were able to view a graph, and then you were asked to draw conclusions and answer questions to analyze what data you did collect. Most students found that their sight reaction times were quite a bit faster than their sound reaction times were faster than their sight reaction times. Now, relatively really small difference, because that was like, oh, I responded in my sight in half a second and my sound was in 0.2 of a second. So they're really close in all actuality, and the amount of reaction time, they're really fast. But your data showed a difference between the sight and the sound, okay? So this week, what I want you to do is look back at the conclusion you were able to draw and look back at the trials that you actually ran. And I would like you to design a new investigation that builds off this understanding or builds off your initial data and allows you to investigate it further, okay? So we are going to go through the process of carrying out an investigation in order to draw conclusions. In that skill, step 1 is asking a question. You want to have something you are trying to investigate. Step 2 is going to be planning your investigation. Step 3 is carrying out your investigation, where you're going to actually collect your data. And step 4 is going to be to analyze your data and draw conclusions, all right? Throughout the course of this week, you are going to do all 4 of those. You have 4 days of class, so generally speaking, you should be able to today watch this video and make a question and write up your question that you want to do. Tomorrow, you can make the plan for your investigation, get everything all sorted out, determine your variables, your test variables, your control variables, get everything settled. And then Thursday, you would carry out your investigation, and Friday, you would go on to draw conclusions. You don't have to pace it out that way. That's just a suggestion of how you might do it. You could totally do all of it today. You could do your planning today, carry it out tomorrow, draw conclusions Thursday, be done Friday. It's up to you how you want to use your time. But throughout this week, you are going to be carrying out your own investigation. All right? So now I'm going to jump into what it looks like for step 1. Writing a question in order to create your investigation. All right, so here we have step 1. Determine your question. What are you wondering? What are the variables in your situation, and what might be having an impact on the outcome? So looking at ours from last week, you examined whether sound or sight allowed for faster reaction time. You might be wondering how age affects someone's reaction time, how the color of an object or the sound and tone of a sound might affect someone's ability to respond. Those are examples of variables you might decide to test. What other setting or factor or variable is occurring in your given situation that might affect your outcome? On the lab guide provided, there are multiple examples of questions that you might ask. You could use one of those for your continued investigation, or you may choose one of your own making. Either way, in this first phase, you need to determine a question that you are trying to answer, a variable that you are trying to test. So for this lab, I'm actually going to go through this whole process with you. The question that I have determined that I want to investigate is, how does age affect a person's ability to respond to stimuli? To do this, I am going to look at different age groups. I'm not going to I don't have access to people of a good systematic increasing of age. So I'm going to actually have my kids help me. They're 5 and younger. I'm going to try and see if my niece might be able to help me. She is 10. And then I'm also going to see if my husband, who's in his 30s, and maybe my parents who are in their 60s are able to help participate in this study. So I know that I can test a variety of ages in order to see what the outcome is with different age people doing the same test. I'm ready to move on to the next part of the process, which is creating a plan for how to control and test my specific variable. So on part 2, you want to plan your test. The most important part here is determining how you are going to set up and test your independent variable, the one that you're controlling. So I want to identify how many different trials I'm going to do. For my question, I'm doing age. So I want to determine how many different age categories I'm going to test. I'm going to do 2 people who are below the age of 5. I'm going to try and have 2 people who are in their 30s, myself and my husband. And I'm going to try to get 2 people who are in their 60s, my parents, to do this. So this way, I have systematically picked people from 3 different sets of age, all about 30 years apart, to see how their age might affect the variable. I also have to be watchful for how I'm going to control all the other variables in this lab. If I'm going to test people of different ages, then every single other variable needs to remain the exact same. We will all do the same color object, the same object itself. We're all going to use the Gizmo format. Everyone will do the same number of trials, and they will all do them in back-to-back trials so that all of the data collection remains really consistent. Having specific, repeatable procedures for a lab like this is really essential to make sure there isn't some other weird factor that it influences how people are able to get this, their data collected. So now I'm on to phase 3. I need to actually do my trials and collect my data. So to do this, I'm going to make sure I have everything set up first. Number 1, I'm going to have a testing environment where my participants can have the exact same conditions each time, as much as possible. So I'm actually going to set up my kids in the office where I usually do my work. They know that's a nice quiet space. They can all sit at the table and comfortably click the button. We did some practice trials, so I know they know how it functions ahead of time and that there isn't going to be error because it's their first time trying it, okay? So I've prepared my kids, my participants, for doing these trials, and I've gotten my space set up. I know that they're all going to be doing the green squiggle every time, or nope, I'm sorry, we decided on the blue star. We're going to do the blue star every time, and I also have my data collection ready. Even though I know that there's a table of data that comes up when I do the Gizmo, I want to make sure I have my own data written down. Some students were telling me that they had issues with the computer not regenerating or not loading right, and they lost a lot of their data, and they had to actually do extra trials because of computer error. I want to make sure that I'm writing down data as I go so I don't have to worry about that. I have decided to do it on paper. You could do this on a doc. I have participant 1, their age, because that's the variable I'm testing. I'm doing 5 trials for each participant. I'm going to record the max speed, the minimum speed, and the mean speed. Now this is given for each trial that they do. I don't have to calculate it, but I might want to go through for each trial and identify in that table of data on the left, which is the max and min. I also have a space here for qualitative notes. Remember that qualitative just means any observations you make. So what if I notice that one of my sons got distracted in the middle, or there was some clicking issue or something that really wasn't about the reaction time? That is a space where I could write down those observations, and that comes into play when I'm trying to draw conclusions. If there's maybe a piece of data I need to end up throwing out altogether, or maybe I'm noticing something totally different as I'm watching participants go through their trials that doesn't have to do with their age, but might be important in the outcome of how their data is. So on this page, I have space for 2. I would do another piece of paper for 2 more people, and I would have all of my data written down in one place. So once you have a plan, you are ready to carry out your investigation as long as you have a place for collecting data and you are ready with the environment that you're doing the collection in. I think that's about enough for today. You should be ready at this point to Determine your question that you want to investigate, what variable you're trying to test. Planning your investigation, how will you systematically change your independent variable while controlling and keeping the other variables. And carry out that investigation. Do your actual data collection and get everything, all your observations and numbers written down in one place. You are ready to go. Please see the assignment in Google Classroom. That has the actual paper copy that you need to be filling information on. It does give these directions again in writing, along with some example questions and ideas for getting you started for step 1 and 2. You do need to make up your own data collection table for step 3 of carrying out the investigation. Tomorrow I will be back with another video that goes through how to analyze your data, what to look for, making graphs, and how to draw conclusions. I thought for right now this is enough information to get you started and quite enough science work for the day. As always, reach out if you have any questions, if you're feeling frustrated or you need a little bit more guidance. I'm happy to meet with you to work through any and all steps of this process, and I look forward to seeing what you come up with. Happy investigation!